Hello YouTube, good day. So here today we will going to review this kind of module. So this is a universal battery charger module. So they sell this and they say that this will automatically turn off the charger if the battery reaches the desired voltage. So you can set the voltage here within these two buttons, the up and the down settings of the voltage, so that the charger will be cut off from this relay. So they are controlling this relay. This will be the AC load and the charger, I mean the AC connection and the charger connection, so that if the battery reaches the desired voltage, the relay will be cut off and the charger will be turned off. But I changed this one, I repurposed this one, since I'm not needed the charger. So instead of the charger to be controlled by the relay, I will going to use this to control the load. So I will be using this in my solar setup, which using 18650 batteries like this one. Here we have here 18650 battery, and this has a different voltage. So in order to obtain a 12 volt setup, we need 3 of this. So 2 and another like this one. So 3 of this 18650, then it will be equal to 12.6 volts, since the full charge of this one is 4.2. So 3 of this, so equal to 12.6. Therefore our controller will be connecting the load when it reaches 12 volts, since it is near to the full charge of this 3 18650, and the load will be disconnected if they reach down to 9.6 volts, because the discharge voltage of this is 3.2. so 3.2 times 3 of this. So I have no other example of this, so I will be using these two as my example. Just imagine 3 of this, so we will have a proxy of this one. Okay, 3 of this, so it will equal to 9.6. So the nominal voltage will be 9.6, and this should cut off the load when it reaches below or near 9.6. So therefore, so here is my illustration. Then we will look at the settings. So the lowest setting, or the cutoff setting, will be 10, and the upper limit, or the upper setting, is 12. So in this test, so the current voltage is 12.2. So as you can see in my power supply, it differs 0.1 volt. So 12.3 is in my power supply, and 12.2 here in the module. So we will try to elevate or increase the voltage. So there's an indicator light here that it shows low voltage for the battery. So instead of an indicator light for full charge and the regular use of this module, I will be using it as an indicator light that the battery is in low condition, or in low voltage, when it is lit. So now it's not lit, so therefore it's 12.2. since the return voltage of the load is 12 or up, I set it 12 or up, so therefore the load is connected already and it will not indicate as low voltage. So let's go or decrease the voltage so that it will trigger the sensor and it will cut off the relay for the load. So I will turn the potentiometer down so that the voltage will go down, like so. So as you can see, it's going down. So it is still good for the battery since we are using 18650. We're not using lead acid batteries. So therefore, it will go down. This will show that the battery is consumed by our load. So the voltage will go down, and then as it reaches 9.6, it will cut off the load and the light will turn on. So there, 10 and 9. It's difficult to adjust the trimmer there. So as it reaches lower than 10, so this module seems to be not as accurate as 0% or 100% accurate, but the settings is 10. The lowest settings is 10. So therefore, when it reaches below 10 or 9 something, it will trigger the relay to turn on, and here you can see the indicator light is on. So therefore, the connection here is terminated. So the load will be terminated. So and then we will now illustrate how the load will be connected back as the voltage increases. So let's turn the knob up. There, 10. 11. Okay. So it simulates that the battery is being charged by the sun, by the solar panels. So 12 there. So as it reaches 12, the load will now be connected. So the indicator no longer indicates that the battery is in low voltage. So therefore, this one is very great in controlling the load of our 18650. So it protects the battery. Since I already checked the BMS of this, so there is no over voltage protection. So the over voltage protection will be now carried by our another module, the buck converters, which can be set into 12.6 or 7, so that the battery will not be overcharged. And then this module will now responsible in cutting off the load when the battery reaches the lowest load or the lowest voltage of 10 point something or 9 or below 10. So there, so 12, then the load is connected already. So as the battery, each of the battery will reach 4 point something or 4 volts. So I modified this one since the review of this module, some of the buyers said that this module is defective, this module cannot be set, this module is dangerous because some of them blew on their faces. So I modified this one to condemn this circuitry here, the AC connection here. As you can see, there is a part wherein the AC will be connected here. So I removed the parts here. So as you can see, I removed these are the parts that I removed. The two high voltage capacitors, this one, and then this high voltage AC capacitor. This I don't know the name of this one, but I also removed this one, and the two diodes here, and in an inductor. So all of this contribute to the AC circuitry of this module, and it causes to malfunction if you connect to AC. It's very dangerous since it is bare module, so it probably overload, or it will have a high voltage spikes, or something that will cause the circuitry to be defective, and it will affect the DC load. So therefore, I remove the AC connections here, and I jumpered the wires here. So I look for the low voltage capacitor, this one. It's rated 25 volts. Therefore, this might supply all the power that is consuming by this circuitry. So I connected it directly to the positive of the battery to be tested. So here, it is connected out to our power supply. So from the positive of the capacitor, I connect a wire going down to the positive of the battery to be tested, and the negative still remains the negative. Then the relay module, since I remove all the parts here, so there will be no connection to AC, and I'm not connecting it to AC. So the normally open connection, I think the normally closed, because there is no connection here. So the normally closed, so the one without a tracing, I connect a wire, a bigger wire that can handle 10 amperes, since the relay is rated 10 amperes. So I connected the wire here, a big wire, and jumper it to our connector here. So here, instead of 4, they are connected to each other, the middle 2. So we can use these connectors to connect our load. So here will be our, what is this? The normally, here is the normally open here, this one. The normally closed in the middle, the two of them, and this is our common connection. So this will be the attachment for our load, the relay connection. So thank you guys, and hope you understand my video. Subscribe and hit like button, and see you on my next review.